Any questions, your voice might be on here. But other than that, okay. For those of you that don't know, I am Miss Johnson,
Miss Wilson,
Miss Griffin,
and
Miss Smith. So I have this beautiful poster here for multiplication, and the words around it are all of the topics that we teach in 4th grade, and every single one of these rely on multiplication. So going forward, we won't touch on anything else the rest of the year pretty much that doesn't require them to be able to multiply, or that doesn't make it easier if they know their multiplication. So just a few things to think about as we get started. Multiplication facts from 1 to 10 was really a 3rd grade standard. So knowing those, knowing how to solve them was 3rd grade. So although we are practicing them in our classes, they should already know. So that step should be done. And then facts times the multiples of 10, so like 5 times 70 or 3 times 400, they should already know as well. Place value is how and what students have learned. So all of these strategies for multiplication and division are based on place value. Even though it sounds confusing and it looks confusing when you guys are looking at it or when I was looking at it to begin with, this is what they know. So everything they've been doing, even with addition and subtraction in 3rd grade, they were place value strategies. So it's confusing for us, but for them, it's not as bad as it looks.
also, if they know a strategy to be able to multiply and they have to take that time to do that, they do know that, but that's not what we're talking about. We tell them that we want them to know their math facts as quickly as they know their name. And that's really important to not have them be stumped.
Because everything else will just be easier if they know the basics when they're dealing with the bigger numbers and fractions. They're not getting stuck on the basic multiplication. And then having a number sense or understanding what a reasonable answer is going to be important. So them knowing that 1,000 times 4 is going to be closer to 4,000, 5,000. It's not going to be 40. All right. Now we get into the fun stuff. So hopefully you all have a paper. Does anybody need it? All right. So you have this paper to take notes with. If you want a blank copy later, more than happy to get you another one. We will be starting on this in our classrooms next week. So this gives you a little leg up on the kids. Follow along, however you want to do that. But, all right, so the first strategy we're going to talk about for multiplication is area model, which is also known as box and cluster. Has a couple other names, but if you're looking it up online, either one of these would be a great name to search. I think she has it. Yeah. So this is how it would be broken up for 2-digit times 2-digit. Your first step would be to start with a box and dividing it into 4 parts. So really what you're doing is you're dividing it for the 90, the tens place, and the ones place. And then the tens place and the ones place again. So if you're doing 2-digit by 2-digit, you would have 4 boxes. And then going back to 3rd grade as well as our first unit in 4th grade, we talked about expanded form. So expanded form for 91 would be 90 plus 1, and expanded form for 45 would be 40 plus 5. So what the students are going to do is they're going to take this, the place value, and they're going to put this on the box. So this box will be like 90 plus 1, 40 plus 5. So this is giving them a visual to match their expanded form with. And then inside of each of these boxes is where they're going to apply that previous knowledge of their multiplication facts and the multiplication facts times the multiples of 10. So this 90 is going to come down. Really hard to write this out. And then this 1 is going to come down. It's gonna make sense, I promise. Okay, so the reason I'm bringing them straight down is because it's easier for the kids to know that this 90 comes all the way down, this 1 comes all the way down before I start bringing these across. So just like on a graph, you're going like this to connect those numbers. So now this 40 is gonna come across, so we're multiplying, so 90 times 40, 1 times 40, 90 times 5, 1 times 5.
Does everyone see why she did what she did over here?
Yeah. And it doesn't matter if you would have put the 45 up here and the 91 over here, as long as what's over here you're bringing across and what's up here you're bringing down. All right, so now we're just going to multiply. So 90 times 40. The kids should all know that 9 times 4 is 36. And they were both in the tens place, so we're gonna bring down those zeros. One times 40, we all know, should know, it's 40. 9 times 5 is 45. And then the 9 was in the tens place. So we just have that 1 0. And in our first unit, we talked about the place value chart and how we multiply times 10, our number is moving over in the place value chart by 1 space, which is where that 0 comes from. So I'm not just pulling a random 0 from anywhere. That was from the first unit. And then 1 times 5 is 5. All right, so now we have our 4 parts, and we are going to put them all together by adding them up.
And hopefully they all know their place value to see how to line up those numbers.
Yeah. And then one of the common questions is, does it matter what box or what order we're adding these up? No, it doesn't matter. I usually line them up biggest to smallest only because it's easiest for them to line up, but it doesn't matter. So 3 zeros and a 5, 5, 5 and 4, 9, 6 and 4, 10 and 4. So 4,095.
Does anyone have any questions, need any help with anything?
So I know it looks like a lot. Okay, but it breaks it down step by step for them, and they understand why they get this answer versus the old school way, just lining it up and you multiply this times this because that's what I'm telling you to do. That gives them no understanding.
And if you think about how we learned how to multiply, that was also a lot of steps. So I don't believe there's more steps in this. It's just a different way of looking at it and gives the visual.
Are there any questions? Huh? Yes. And a lot of times the students get this and then they mess up on the addition because they don't think it's important anymore. They don't line it up, they add wrong, they're not carrying that 1. That is the most common mistake. Anybody? Okay, good if I go to the next one? Okay. All right, so same thing area model, but this is 3-digit times 1-digit. So same thing, we're going to break it up into expanded form, which is 200 plus 80 plus 4, and then this is just a 9.
So because there's 3 digits in that first number, she's going to do 3 boxes going down. A box per digit.
200 plus 80 plus 4, and then just the 9 on the side.
Since there's only 1 digit there, there's only 1 box going that way.
So again, it doesn't matter, like if you wanted to make a long box and break it into 3 boxes and then the bigger number being down the side, it doesn't matter as long as you're keeping that expanded form together. All right, so same thing, the top's gonna come down, the side is gonna come over, so 200 comes down, 80 comes down, 4 comes down, we're multiplying, whoops, 9 times 9 times 9. 9 came across, big numbers came down. And we're going to multiply, so they should all know 2 times 9 is 18. It's in the hundreds place, so we still have those 2 zeros. 8 times 9, 72. In the tens place, we've got 1 0. 4 times 9 is 36. And then what are we gonna do? There we go.
And watch that place value.
6 and 5. That will make a little bit more sense.
I promise y'all, I love this way better than what we learned way back when.
Is this y'all's favorite?
It's not, yes.
This is yours.
And we usually just introduce all the different strategies and let the students choose the one that works for them. And most of them will choose this.
Yeah, the box.
But be careful that, like, if your student prefers this way, try to go ahead and let them do this way, not do the way that you're more comfortable with.
Yeah. That was the other thing I was gonna say. Okay, so they're going to learn a variety of ways, but on like a test, they can pick whatever strategy they want to use it.
Are they learning different strategies, or are they just learning this?
They're gonna learn this one, and then the next one, you guys don't teach lattice, right? Or any of those other ones? Yeah, okay. Just us two. Okay, so there would be 2 that we're gonna teach. And then another question that we've gotten a lot, like last year, is will it be wrong if they use the standard algorithm? And the answer for that is it depends on the question that's being asked. If it says, solve this problem, and that's all it says, then no, they can solve it however they could use the standard algorithm if they're good at it and get it right. But if it says multiply these numbers using a place value strategy and they use the standard algorithm, then it's wrong because they did not use a place value strategy.
What is standard algorithms?
That's the old school way.
Okay, so the
Yeah.
way we learned where we're
Mhm.
multiplying the
Yeah.
number times number, then cross over to the number, okay.
Yep, so that's standard algorithm, the old way. Any questions? All right, so now, this is my favorite way because I don't like drawing the box. All right, so this is partial products. It's also place value because it still forces them to understand what these numbers really mean. So we are going to line it up like the old school way. But instead, we are going to multiply it by the place value. So, like you would do in the standard algorithm, the way you learned it, you would do 9 times 3. I write it out to the side. Do you guys write it out? Okay. We all write it out to the side just so the kids can make the connection would it be required? No. But so 9 times 3, we're gonna write it underneath, would be 27. Now, the old way, you would say, okay, 9 times 6 is 54. But that's not a 6. And that teaches the kids that this only has the value of a 6. But really, this is a 60. So we would really do 9 times 60, which would be 540. Not 54. So then we're gonna go over to the 4. This is not a 4, it's a 40, and we're gonna do 40 times 3. 40 times 3, 120. And then 40 times 60, 2,400. And then just like we did with the box, we are going to add it up. So some of the kids don't like drawing boxes. They also write really sloppy and they can't draw the box big enough to fit their numbers in. And they tend to prefer this one.
This is most, I think, more similar to what we call standard algorithm. So this is more similarly related to what you probably know as parents, with the exception of us adding the place value so that we know where that original number came from.
So that way they have the true understanding of what they're doing and why they're doing it, not just because we're telling them to.
And you all said in each of your classes you're gonna teach both.
Yes. Yeah.
Does anyone need any extra help with anything?
All right. Now we are going to switch to division, and it is on the back of your paper.
This thing is fun. It is fun.
Okay. So, partial quotient, also known as Big 7, is the place value strategy that we're going to teach for division. Again, it's based off of place value, not just here's a step, I don't know why, but here's a step you're going to do. We want them to truly understand what division is, why they're doing it, and why it works. I am going to solve this one problem 2 ways. I'm going to solve it as if I don't know my multiplication facts, so I'm having to work it out and take more steps in order to do it. And then I'm going to do it as if, well, I know my multiplication facts. All right, so it's also called the Big 7 because we can take this and bring it straight down, and then it kind of looks like a 7. And that just helps the students divide where their work is.
And if you
So-
did Google Big 7,
Yeah.
you would get this.
So these are the names. I tried to include the names if you are looking for it at another time on Google, or practice or whatever. That way you know what to search. Okay. So 639 divided by 9, same thing. I need to see how many times 9 can go into this whole number. So I'm going to think 9 times what can get me close to this. So if I am somebody that doesn't know my multiplication facts, I'm going to start with my tens, my hundreds. So 9 times 10 would be 90, which is nowhere close to this. But 9 times 100 is 900, and now I've gone too high. So I am going to stick with my 9 times 10, because that's what the students are going to do when they're trying to figure it out. So they're going to say, okay, well, 9 times 10, I am going to put a 10 over here. And then I am going to subtract 90 from it. And then again, they have to make sure they are subtracting right, or the whole thing is going to be thrown off. Now, students, will do this,
10, 10, 10, 10.
10, and they will keep doing times 10, and they will subtract 9. And they will subtract the 90 from it until they get to 0. And it takes forever. Okay, now, you would keep going until you get to 0. But if you know your multiplication facts, which is why we've been stressing knowing our multiplication facts, they should recognize that this 63 connects to our 9. So 9 times 7 would get us 63, which means 9 times 70 would be 630. So they can put this whole 70 here and do 630 and subtract. And now they've got 9 left. 9 times 1 is 9, 0. And this over here would be their answer. And you would add that up, which would give you 71. Versus over here, they would do it over and over, and they would do it 7 times, and then they would be able to subtract that last 9.
And that'll take up a whole page.
Yes, and they will do it. So, this is why knowing their multiplication facts, even though it's division, is so important.
We also tell them they keep going until they get to 0 or until they get to less than 9 or whatever the number is there.
And if they keep doing 10 all the way down, some of the students will start making mistakes.
Yeah.
In that subtraction. Mhm. So they can pick whatever number they want. And that is the thing I like about this division. It doesn't limit the kids to it has to be this way or it's going to be wrong. I mean, they could multiply it times 5. They could do times 50. If they know 9 times 50 is 450, but they didn't recognize this 63, they could still subtract 450 from it and work from there. So we could have 20 different students in our class, and every single one of them could do it a different way, but get the same answer based on the multiplication facts that they know.
One of the things I actually have my students do is I'll have them write their 9s off to the side so that they can figure out where that friendly number is. So they're gonna do 9, 18, 27, and then I always tell them choose the number that's closest to the number that you're trying to get to. And then they know if they add the place value, the zeros, they know that all they have to do is add that to that number as well. So mine will have their multiplication facts off to the side.
Like,
That's the way I'll teach them, is to have their facts off to exactly just like that. And I would just tell them it's another way of remembering your facts if you don't know them, by writing them off to the side. And eventually what I'll see that they will do, they won't even write 9 times 1, they'll just write 9, 18, 27. Initially, this is what I will show them, what Ms. Johnson showed now, is that I will tell them, write your facts for the 9.
because then they should have noticed the 63. Oh, wow, look, it's right there. And then if it was 629, well, then they would just go the 54. Closest. If it's not exact. Any questions about this?
Another example.
Okay. All right. All right.
Just in case they were gonna ask.
Right. All right, so we're gonna start out, we're gonna make it look like a 7. We're not gonna do a slanty 7, because then their numbers aren't lined up. So our 7's just gonna go straight down. All right, so I'm going to multiply, I know 2 times 2 is 4, and it's in the hundreds place. So 2 zeros. So 2 times 200 would give us 400. You could have done 240 or whatever, but just picking a number. Subtract 8 2 times 40 is 80, subtract 5, 2 times 2 is 4, subtract, we get 1. So we are still adding up the outside here to get 242. And then this number is smaller than our divisor, so this is our remainder. That is that leftover piece. So if it's exact,
Can we do it with the 240 instead of 200?
Oh, yeah,
yeah. You want me to do it?
Yes.
Yeah, okay.
okay.
Okay, so 485. So 240 would be here, making it 480. Subtract 5 left over. 2 times 2 is 4 minus,
Wait, why'd you multiply by 2?
because I had 5 here left after I subtracted, and I know 2 times 2 is 4.
Oh, gotcha. Okay, gotcha.
And then 1, so we would still get the same answer up here, 242, with a remainder of 1.
Okay, thank you.
So as the numbers get bigger, because we'll go up to 4-digit divided by 1-digit, it's the same thing, they just need to know their place value.
In their multiplication facts.
Well, and their multiplication facts.
Can't say that enough.
Yes. What questions do you have?
Practice getting it.
What type of homework? What type of
Right, right, right.
633.
Oh, okay. Do you want me to do another one?
Yes, yes.
Division or multiplication? Division? Alright. Alright, let's do
Huh? A 4-digit?
4-digit? Okay. Let's do. Alright, so 4,385 divided by 6. Alright, so none of this matches up great if I were to write out my 6s. We'll do that. 12.
Be thinking about where you would start. Does anyone know where they would start?
With the what?
6 times 7.
With the 6 times 7? Okay. Would anybody else start somewhere different?
I probably would start with 6 times 5 because maybe I have difficulty with my fact, so I might start there.
Okay. So let's start with the 42. So 4,385. The first two numbers would fall between these two, so they would know they have to, well, they should know they would have to go under because we can't go over, we can't split anything if there's not enough of it. So 6 times 7 is 42, and then there's 2 more places here. So I gotta keep them over here. So 6 times 700 would be 4,200. Subtract 5, 8, 1. I notice 18 here. 6 times 3 is 18. So I can do 3. 6 times 3 is 18. I have another number here, so it has to be 30. Subtract. Get 5.
It's smaller.
It's smaller, so we have to stop.
So 730 is a negative 5.
Yes.
Correct.
Add these up. 730. Remainder 5. And they will have to understand what this remainder means and whether or not it's important when we get into word problems. Is it making sense? Yeah.
It's just changing up your thought process.
Yeah. That's the biggest thing. And the students, I mean, that's what they mess up on, that addition, that subtraction. Giving up on those things and rushing through them because they don't think it's as important as the other stuff, but it's equally important to get those right answers.
If I was that student that, when I learned the algorithm, it was very hard for me. I didn't understand what I was doing. I didn't understand why I'm putting this number here and what, I didn't get it. This shows them why they're doing what they're doing.
Yeah. And they've always worked with place value. So for them, the place value understanding comes a lot easier. Another thing that me and Ms. Wilson talked about today on the playground was I struggled with my multiplication growing up because I couldn't just memorize it. And even now, like 6s, 7s, they will still trip me up. But like I tell the kids, you don't have to know every single one immediately. If you know most of them, you have strategies that get you where you need to be. So like 6 times 7, if you know 6 times 6 is 36 because it rhymes and you can add 6 more really quickly, you can get your answer, even if 7s is not a strong point. So.
And, I know, for instance, like in my class, the next couple of days, we'll be going over our multiplication table just to kind of make our students comfortable with their multiplication facts. I think most of them, everyone knows their 0, 8 times 0 is 0. Everybody knows their 1s, that is whatever the number is. They usually know their 2s, it's doubling. 3s are tricky, 4s are tricky for some of them. 5s, they all know, it's skip counting. 6, 7, 8, that's where we struggle. There's strategies for 9. So your answer to anything multiplied by 9, equal 9, and we got some hands here, I'll teach them that. And then there's another one where they know, okay, I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I'll go back the other way, 0, 1, 2, 3, 5, 6, and then they know their facts that way. 10s they know, 11s they know until they get to 11 times 11, and then 12, same thing. So at the end of the day, when we go through the multiplication table, there really are only about 16 multiplication facts that children really will struggle with. So it'll be like your 4 times 6, 6 times 7, but they know 6 times 2, so you don't have to worry about that. So when we say they don't know their 6s or they struggle with their 6s, it's only a few of those facts. So we'll go through that multiplication table and we'll focus on the ones that we know for sure can be the challenging ones. Same with 11s, like they get the 11s, it's just 11 times 12 and 11 times 11. Those are the only 2 11s that they'll struggle with. So that's what we'll do again as we're transitioning into the multiplication.
So, and that's good when you work with them at home on their facts. That's also good to point out, yes, you do know this. Yes, you know this one, so now we gotta get to this one.
Will that recording be good with us?
Yes. Yes, I can stop it.